Following on from our Introduction to Differential Pairs video, we now introduce some advanced tools to aid the process. Two important requirements when routing your differential pair tracks are, firstly, the track length and skew, and secondly, the proximity of the differential track regarding other tracks and components. First, we illustrate two features that allow a real-time display of the skew and the estimated final differential track length. The first tool presented is the head-up display. To enable the head-up display, go to Settings, Preferences, Display. Check the box, Show Head-up Display, and include unrouted lengths. Now launch the Design Technology and select the Net Class tab. You may scroll along and edit any cell. However, a nicer presentation of the data is to select the name and click the Edit button. Here, a form is presented with the data appropriately grouped. Enter a value for the maximum required skew length. The design technology is then updated. Now start routing the differential pair. As soon as the tracks are started to be placed, the head-up display will provide real-time data. As we have set a maximum skew, the skew data will be shown in green when within the limit, and red if we exceed the limit. Once we complete the track, the head-up display is closed. But what was the final skew and track lengths? You can generate a differential pair report, or you could use the Nets dockable bar as part of the process. Let's now explore the next dockable bar. Right-click the margin and select Nets. Expand the area so that you have a larger form for configuring. Click Options and you will see many available settings to configure. The Nets bar is not just for differential pairs, it can be used for any nets during the design process. Here we leave everything as it is, but for a design with more nets you would select the differential pair from the Nets class options. Selecting columns, you can control what you wish to display. For our demonstration I do not require pads and class, so these are selected and removed. I do wish to display differential pair skew and net length, so these are added. The details of the routed differential pair are now displayed. Adjust the net bar width to suit your requirements. Clearing the differential pair routing, we now start again. The net bar is displaying the same information as the head-up display. You can decide which you wish to have active. The head-up display allows the maximum PCB editing area and the data close to the point being routed. Here we briefly illustrate routing without the head-up display. The Nets bar keeps the PCB area uncluttered but of reduced area. Now we move on to the second essential task of routing differential pairs. Now let's consider the spacing requirements when routing. Here we have a few components and tracks to navigate. When placing the tracks, how can we ensure that the spacing rules for differential pair are complied with? Differential pairs will have a larger spacing requirement than normal track-to-track and track-to-component rules. Currently these are all set to 7th hour in the Design Technology spacing rules. In the Design Technology Nets tab, we can set a guard spacing, and here I have set 25 thou. In Colours on the Settings and Highlight tab, we can enable Show Clearances. Back to our PCB editing, we can select components, and as we start to move them, any track or pad that encroaches into the guard band will be highlighted. The highlighted guard band will be cleared once outside the guard band, and the component can be placed. This process can then be repeated for all components in the vicinity of the differential pair tracks. The process of placing components approximately where required, then routing the differential pair tracks, followed by optimizing the component positions, is probably the optimum for many designs. If the components have a relatively fixed requirement on their position, you can route the differential pair after component placement, but as shown, this may be more difficult and time consuming. You will notice that the auto start and auto finish did not complete the differential pair tracks. The reason for this is the start and finish pads are in a location that breaks the guard band spacing rule. You can manually complete the tracks, but a simpler solution is to start routing short differential pair stubs with the guard band set at 0. These stubs at both the start and finish pads should be of a length to clear the pads that the guard band will be set at. Now set the guard band to required clearance. Start completing the differential pair. Note the white dots when you are continuing from the differential pair stubs. To summarise, we have shown the tools available for real-time track length and skew, and how to ensure the differential pair is routed with a guard band spacing from other tracks and components.